In this video, I'm going to go over the Mach 1 review, which is our first test of this semester for geometry. So given the following diagram, what are the slopes of the lines, and classify the pair as parallel or perpendicular in what it's going to have on the test, or neither. Okay, so we want to pick 2 points on each line. So I'm going to do this first one, this one, okay? So I'm going to find a point where it crosses right there, and it looks to me like it also crosses right there. So we know it's rising because it's going up from left to right. So we're going to count 1, 2 up and 1, 2, 3 over. So the slope of the blue line is 2/3. And this is what you're going to have to do on the test, okay? So here we go with the red line. There's where it crosses on the grid. We can see where the two coordinates x and y cross. So here again we're going up 1, 2 and over 1, 2, 3. So m is equal to 2/3. So because those lines have the same slope, we can say they are parallel. Okay. Now the next one says, given the following diagram, what are the slopes and lines, and classify the pair as parallel or perpendicular? Well, I'm pretty sure we all know they're not parallel, but again, neither will be one of your choices on the test, so you need to be watching for that, okay? So here again, I'm going to do one of the lines in blue and one in red. Actually, let's do this one in blue. We'll do this one in blue and the other one in red. Okay, so once again, we're looking for where is it? Perfect XY coordinate there. And it looks like there's another one right here. So when we do the blue line, we're going 1, 2, 3 up and 2 over. So this is 3 up and 2 over. That's the slope of my blue line. And so we're going to do the same thing with the red line. And I see that it crosses right there. And it crosses right there. And we know that that line is falling, is negative because it's falling from left to right. So this is going to be negative for sure. And it's going down 1, 2 and over 1, 2, 3. So down 2 over 3. So those are perpendicular slopes because they are not the same sign and they are flipped of one another, or what we call reciprocals. Okay, so these are perpendicular. Okay. So the next one says find the equation of a line that is parallel to y equals negative 5x plus 2 and passes through the point. So we're going to find the slope by using the equation y equals mx plus b, realizing that that's our m right there. So m is equal to negative 5. Then we're going to use the points x and y over here. That's a coordinate point right there to plug those values into the equation y equals mx plus b. So y is negative 3. M is negative 5. X is negative 3. Sorry, did that wrong. X is 2 plus our b. We're solving for b. So this is negative 3 equals negative 10 plus b. How do we get rid of a negative 10? We add 10 to both sides, right? So that's what we're going to do. And 10 minus 3 is 7. So b is equal to 7. Now remember, what we do here is we plug in our m and our b into the equation y equals mx plus b. And that's how we get our formula. So y is equal to, here, again, our m. We plug in the m and we plug in the b. 5x plus 7. Remember, most equations for lines have x and y in them. The only ones that don't are vertical or horizontal lines. So with number 4, it says when placed on a coordinate plane, Main Street has an equation of y equals 1/4 x minus 2. Park Street is perpendicular. Oh, the key word up here obviously was parallel, right? To Main Street and goes through point 3, negative 5. What is the equation for Park Street in slope-intercept form? So once again, we're going to pull our slope, which is right there. So m equals 1/4. There's my x value, there's my y value. Plug in those again into the equation y equals mx plus b. So our y is negative 5. And then we're doing the perpendicular slope. Okay, you see the perpendicular slope right here? So we're going to say m perpendicular is going to be negative 4, right? So we're going to multiply negative 4 times our x value, which is 3, plus our b, okay? So this is going to be negative 5 equals negative 12, because negative times positive is a negative, plus b. We're going to add 12 to both sides. And 12 minus 5 is 7, right? So this is 7. B is 7 here, and that's our new m. So our equation here is y is equal to negative 4x plus 7. So when it comes to these properties, guys, remember that A applies to everything, and so does F, okay? So opposite sides are parallel and congruent, and diagonals have the same midpoint. Those apply to all the shapes. Diagonals are perpendicular. This has to do with what? A square and a rhombus, because it's a property of a rhombus, and a rhombus is a square is a rhombus. Then we have consecutive sides are perpendicular. So this would be our rectangle and our square, right? Perpendicular means they form right angles, and we know that rectangles and squares have right angles, right? All sides are congruent. Everybody should know this one as well. That would be what two? A square and a rhombus. Y'all see that? And then diagonals are congruent in a rectangle. And remember that a rectangle and a square is a rectangle, right? So again, we have our rectangle there, and then a square is a rectangle. So these are properties that you absolutely must memorize because they are going to justify your answers pertaining to these shapes on the test. The next one says our points J, K, L, and M are the points J, K, L, and M, the vertices of a parallelogram, rhombus, rectangle, or square, or quadrilateral, or just a quadrilateral. Explain using the properties. So I'm going to go ahead and plot these, and I'll come back to you in a minute. So looks to me like JKLM is a square, right? So how would we prove that? First of all, a quick way is to look at the diagonals. So we're going to look at these two diagonals right here, JL and MK. Okay, so if these two diagonals are congruent, then we can say that this is a square, right? So this is 1, 2, 3 tall, and 1, 2, 3, 4, 5, 6 wide, right? So 3, so this is going to be JL is equal to the square root of 3 squared plus 6 squared. I think it was 6. Was it 6, y'all? Yep. Okay, so that's going to be, wait, was it 3? Wait, 1, 2, 3. I don't know why I had 4 on my paper. So 36, 9 plus 36 is equal to 45, right? And if you were to say, what is that in the simplest radical form, we could say that's square root of 9 times square root of 5, which would be 3 square root of 5, okay? Now let's compare the other one as well. Now we're going to look at MK, okay? So here again, we got 3 down, and 1, 2, 3, 4, 5, 6 again. So this is going to be the same, 3 squared plus 6 squared, which is, we know now, the square root of 45, which we also know is 3 radical 5. So because JK and ML are equal, we can say the diagonals are congruent. Now here's the thing. This is also true of a square, okay? So we need to say a little bit more information if we're going to say that this is true. So we could also say what? That opposite sides are congruent. Now how do we know that? Because we can actually count them here, okay? So let me pick a different color. So here, if we do MJ and LK, well, MJ is 3 tall, and so is LK, so we could say MJ is equal to LK, okay? Then we can talk about another pair of sides. We could talk about JK, let's do this in a different color, JK and ML, right? So we would say JK, and again, this is 1, 2, 3, 4, 5, 6, and that's 6, okay? So we could say JK is equal to ML, and this is saying that opposite sides are congruent. Now, it takes both of these conditions for us to say that this is a rectangle. Otherwise, it could also be a square. Down here for number 7, again, going to do the same thing. I'm going to plot the points and come back to you. So what I typically like to do with my students after we plot these points is say, look at the image. So I'm pretty sure that all of y'all could say this is not a rectangle and this is not a square because we have no right angles, right? So it's either one of two shapes. It's either a parallelogram or it is a rhombus, right? So let's go ahead and let's compare these diagonals. So we're going to compare D at B is slope. Okay, and we're going to compare that to our AC slope, okay? And what we're looking for here are they perpendicular? Because if they are, then we can verify that this is actually a rhombus, okay? So, we are going to find dB. So when we do dB, we're going, it falls from left to right. So it's 1, 2, is that 2? Yeah. And then 1, 2. That's where it was, y'all. Wait, where's B at 5, 3, 1, 2, 1, 2. So this is -2 over 2. So that's a slope of -1. Okay, now we're going to check AC slope. So this one is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that is 6 over 6, which is equal to 1. Now remember, the way you check these to make sure that they are reciprocals of each other, you should multiply them by each other. And if you get -1, that verifies that they are reciprocals. So we can say dB is perpendicular to AC. So this is diagonals are perpendicular. Okay. Oh, and by the way, up here, we never did say, it's a rectangle, isn't it? That's what it asked us to find. We verified that it was a rectangle with our properties here, but we never said it. Okay, then what's the other thing? What differentiates a rectangle, a rhombus from a parallelogram? It has congruent sides, okay? All the sides are congruent. So let's count. So we're going to go up here, 1, 2, 3, 4, and over 1, 2. And right here, we're going up 1, 2, and over 1, 2, 3, 4. So we verified that those are 1, 2, 3, 4, 1, 2. I don't know how that moved, but it did. And this one is 1, 2, 3, 4, 1, 2. Okay, so all of them were 4 and 2, right? So I'm just going to say AB is equal to BC is equal to CD is equal to DA, because all of them are the square root of 4 squared plus 2 squared, which would be 16 plus 4. So all of them are equal to the square root of 20, right? So this is saying all 4 sides are congruent, okay? And that's what proves that this is a rhombus. Okay, so given the following points on the graph ABC, if we want to create a figure ABCD into a square and a parallelogram, then what should the coordinate pair be for D? Okay, so here's the deal. On the quiz, y'all, these were not in ABCD order, and that's why some of y'all missed these questions on the quiz. And we did talk about that. Okay, so B, we're going to go from B to find the slope, okay? So from B, we're going to go down 1, 2, 3, and over 1. So from C, we're going to go down 1, 2, 3, and over 1. So this is where I think D is, and we're going to verify that with the other side. So again, I'm going to go from B to C. I'm going up 1 over 1, 2, 3. So from A, I'm going to go up 1 over 1, 2, 3. So we ended up with the same point twice. So that really does verify that that is our point, right? Okay, so now the next one says, again, we're going to do the same thing, only this time we're going to do it with A, B, C. Y'all see that? Okay, so once again, we can go from B to A or B to C, but that's how we want to move. So I'm going to go from B to C, so I go 1 right, 2 up. So from A, I'm going to go 1 right, 2 up. And then same thing over here with B to A. So I'm going 2 left, 1, 2, 3 up. So from C, I'm going to go 2 left, 1, 2, 3 up. Okay, so either way, we get our point for D here at -3, 4. Remember, you're always going to go from where those two sides come together. All right, so this is the formula for slope. And so all we're going to do, x1, y1, x2, y2 is populate this formula. 8 minus 6 over 9 minus a minus 3. So this is going to be a plus. So that's going to be 2 over 12, and that means this slope is 1/6, okay? Again, x1, y1, x2, y2, so this is going to be -3 minus 5 over -1 minus 7. That's going to be -8 over -8, which is a positive 1. All right, then we're going to do x1, y1 again, x2, y2, 11 minus 8, and 13 minus 0. So that's going to be 3 over 13. Can't simplify that one at all, can we? Nope. All right, so this next one, let's see. I'm erasing this so we don't muddy the waters here and we can talk about it. Okay, so it says, given the following points on the graph, find the length of each side and perimeter to the nearest hundredth. So we need to find the length of each side. So we're looking for WX right here. So we're going to find the rise over the run. Okay, so this was 7, and that's 2. I'm going to do this opposite side over here too, because it looks to me like it's probably congruent. 7 again, yep, and 2, okay. So when I'm looking for WX, it's going to be equal to, what is that, YZ? It is, Y. Because they have the same side lengths for this right triangle. So remember, we're going to do this with Pythagorean's theorem. So we're going to do 7 squared plus 2 squared. That's going to be equal to 49 plus 4. So that's going to be the square root of 53. Okay, now know when we're going to have 2 of those, right, when we try to find the perimeter. Now we're going to talk about this other side, WZ. Okay, so this one's 1, 2, 3 up, and 1, 2, 3, 4, 5, 6, 7 over. Okay, this one's 3 down, and 1, 2, 3, 4, 5, 6, 7 over again. Okay, so when we talk about WZ, and it's equal to X, what is that, XY? Why? Because, again, the triangle sides of our right triangle are the same. So we're going to do 7 squared plus 3 squared this time. That's equal to 49 plus 9. That's equal to the square root of 58. So if I want to find the perimeter here, I'm just going to go 2 times the side 53, square root of 53, plus 2 times the side of the square root of 58. And you can put that right in your calculator. And when you do, where's my lovely answer? It is 29.79. It says to the nearest hundredth. Remember, that's 2 decimal places. All right, this next one says a line segment has one endpoint at here. So that's one of our endpoints. And then a midpoint of 1.5. And then it says locate the second endpoint. Now, we did a hack for this, if you guys remember. If we do 2 times our midpoint, okay, then that equals either X or Y plus or minus our X comma Y. Okay, so what do I mean by that? So if we do 2 times the 1 comma 1.5, that gives us 2, 3, right? So we're going to set that equal to 2, 3 over here on our left side. This is our X, that's our Y, so we're just going to say equals X minus 3 and equals Y minus 1. Now, how do we get rid of a negative 3? We add 3 to both sides, right? And we add 1 here. So our X here is equal to 5, and our Y here is equal to 4. So our ordered pair is 5, 4 for the other endpoint. Okay, now if you had to find the midpoint, you would add the 2 points, the 2 endpoints together and divide by 2. So on this next problem, it says we're going to find the difference and put in standard form. So we're going to put this in standard form first. 2y to the third plus 5y squared minus 3y minus 9. Now I'm going to go ahead and change all these signs to plus, to minus, and minus, and I'm going to make that a plus. So now I'm going to add whatever these are in the sign that they are. So that's a 7y, that's a minus 6. This is now minus 4y squared. Now I can just do what's there, okay? So this is going to be 2y to the third plus y squared plus 4y minus 15. We're going to do the same thing with the other one, okay? So I'm going to do 7v squared minus 4v. Again, we're going to do minus, plus, minus, because we're going to change that to a plus, okay? So now when we add this, we've got a 3v to the third. Don't have anything like that in the top one. And then we're adding to it down here a 9v. And then we're also subtracting from it a 5, okay? See that? So we can only line up the terms that we have. So we've got our 3v to the third plus 7v squared. And 9 minus 4 is 5, so this would be plus 5v and then minus 5. So I'm just making sure that I did everything right. Okay, so now we're going to find the product down here, and we're going to do this with the box method. And I'm going to do this again in descending order. And I'm going to do that because we'll be able to see our like terms, okay? So I'm going to put the 7x there and the negative 5 there. So all those are my terms across the top. Then I've got my 4x squared here. And then a negative, oh wait, I didn't do that right. I'm going to put that negative x to the third at the top. And then my 4x squared, and then my negative 8x, okay? So now we're going to go ahead and multiply the first two terms together. So negative 1 times 6 is negative 6. X to the third times x to the second. X to the third times x to the second means we're doing x to the 3 plus 2. So that means this is x to the fifth. I'm just showing y'all in case you didn't remember. This is x to the fifth. So anytime we are multiplying bases, we add their exponents. So then we got a negative 7 times negative 1. So that would be negative 7, and x times x to the third is x to the fourth. I'm going to go ahead and keep going with that one in that slant, okay, in that diagonal. So I got 6x squared times 4x squared, so this is 24x to the fourth, okay. I'm going to keep doing these in different colors. Negative 5 times negative 1 is positive 5, and that's x to the third. Then we got 7x times 4x. 7 times 4 is 28. And x squared times x is again x to the third. And then we got a 6x squared times a negative 8x. So 6 times negative 8 is negative 48. And then we got an x squared times an x. That's an x to the third again. Going to find me another color here. Okay. So now we're going to do negative 5 times 4x squared. So that's going to be negative 20 because a negative times a positive is a negative. Then we got 7x times negative 8x. So that's going to be a negative because a negative times a positive is a negative. And that's going to be negative 56x squared. Then we finally have over here our lone term of negative 5 times negative 8x. So that's going to be positive 40x. All right, so now we're going to bring these down. So we got our negative 6x squared, or x to the fifth, sorry. Then we got our red term. So we're going to do 24 minus 7. So that's going to be 7, sorry, what am I doing? Plus, right? It's going to end up being a plus 17x to the fourth. Then we got our blue terms. So negative 48 plus 28 would be negative 20 plus another 5 would be negative 15x to the third. Then we got a negative 56 and a negative 20. That's kind of nice because they're both negative, right? So that means that's going to be minus 76x squared. And then we got our 40x left. Okay? All right, we're going to do the same thing with the next one. So we're going to write it in descending order like we did before. So this is going to be negative 6s squared, then negative 5s, and then 4. And then over here we got a 3s squared and a negative 2s, okay? So we're going to multiply these terms together. Negative 6 times 3, that's negative 18. S squared times s squared is s to the fourth. Okay, we're going to do a negative 5s times the 3s to the second. So that's negative 5 times 3, that's negative 15. S squared times s is s to the third. We're going to go down here and do the negative 6 s squared to the negative 2. Negative 6 times negative 2 is 12, right? And then s squared times s again is s to the third. All right, now we're going to do our 4 times 3, that's 12, and that's going to be s squared. Then we got a negative 5 times a negative 2, that's a positive 10. And s times s is s squared again. And then we have our 4 times our negative 2s, so that's going to be negative 8s, right? So here we go, combining our like terms again. So we got our negative 18s to the fourth. 12 minus 15 is going to be minus 3s to the third. 10 plus 12 is going to be 22. 22s squared. And then we got our negative 8s left. Okay? Watch for, if you do this in descending order, then you can always find your like terms in the diagonal if you write the problem in descending order. So this next problem, we're going to add the three sides together because it tells us to find in simplest form an expression that represents the perimeter of the triangle. So we're going to add 9b plus 8 plus 12b minus 8 plus 12b minus 8. So 12 plus 12 is 24, plus 9 is 33, so this is 33b. And a couple of these cancel each other out, right? So we're just left with that negative 8. So that's our answer there. Now down here, we're going to do the same thing we've been doing before. This says the sides of a rectangle, rectangular yard are 9 minus 12d plus 4d squared and 7d squared minus 5d plus 8. What is the area of the yard? Okay, so that's what it's asking us to find. So we're going to do, I'm going to write it in descending order first again. 9d squared minus 12d, and then 9. And then over here, we're doing 7d squared minus 5d and our 8. So once again, we're going to work this through. 7 times 4 is 28. D squared times d squared is d to the 4th, right? Okay. Let me scroll up here a little bit so I can have a little more room to work. Then we got negative 12 times 7. That's going to be negative 84. Just double checking my math. D to the 3rd, right? And then we're going to do 4 times negative 5. That's negative 20. That's also d to the 3rd, okay? Now we're going to do 9 times 7. That's 63, and that's d to the 2nd. And then we're going to do negative 12 times negative 5. That's 60, d squared. And we're doing 4 times 8. That's 32, d squared, right? Now, if I can get my green up there. 9 times negative 5, that's negative 45, and that's going to be a d. And then we've got negative 12 times 8. That's negative 96d. And we got one more down here, which is our 9 times 8, and that's 72, right? Okay, so we're going to write these again in our colors, just to kind of highlight what we're doing. So this is 28d to the 4th. And then we got 2 negatives there, so they're just going to combine, right? So that's going to be 104 minus 104. That does not look like a 4th power, y'all, sorry. 104, and then this is d to the 3rd, right? Okay. Then we've got all 3 positives, right? So we're just going to combine all 3 of those, and we're going to get 155. So this is plus 155, d to the 2nd. Then we got negatives for the next one, right? So we're going to just combine them as well. So we're going to get minus 141d, and then we've got our 72 left, right? Plus 72, okay? Remember, if you write these in descending order like I did, you're going to get your diagonals are going to have your like terms. The next one says Archer's Ag STEM program is making a rectangular vegetable garden. Rectangular vegetable garden, okay? So it says if the width of the garden plot is 2x plus 4, and the length of it is 3 feet longer than the width, so that would be 2x plus 4 plus 3, which means this is going to be 2x plus 7. What is the polynomial expression for the amount of fencing needed to surround the plot? So this is just a rectangle, right? So we need perimeter. Isn't that what that means if it said the fencing around? So we're looking for perimeter, okay? So we've got 2x's plus 4's, right? And we got 2x's plus 7's. So we could go 2x plus 2x plus 2x plus 2x. That's 8x, right? We got 4 plus 7. That's 11. And 11 plus 11 is 22. So that's our answer right there when you add up all 4 sides. So number 17 says, are the triangles below right triangles? If so, why or why not? And if so, what statement can be made about the sides and where is the right angle? Okay, so I think that the right angle might be at X here. Kind of looks like there might be a right angle there because Y and Z look like acute angles. So we're going to compare these sides. Okay, so we're going to find the slope of XY. So to find it, we're going to go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. Well, 4, 6, it reduces to be 2/3. So if this is a right triangle, then XZ should be negative 3/2, right? So let's see if it is. So XZ, let's see what its slope is. Well, first of all, we know it's negative, right? We're going to go down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, 7. Look at those. are those, one is positive, one's negative, so we're good for that, but they are definitely not reciprocals of each other. We did not flip 2/3 to get 6/7, did we? No. Okay, so the answer here is no. They're definitely not right triangles. Okay, we're going to do the same thing over here, and it looks like y and z again are acute angles, so I think again that x is going to be where my right angle is. So we're going to compare xy slope. Okay, so we're going to go over 1, 2, and up 1, 1, 2, 3, 4, 5, 6, 7. So that's going to be, and that's falling from left to right, isn't it? So it's going to be negative 7 over 2, rise over run. Okay, so now we're going to compare that to xz. Okay, so here we're going over 1, 2, 3, 4, 5, 6, 7. That goes on the bottom, right? And up 1, 2. Remember, it's rise over run. And this one is positive. So those are reciprocals of each other, right? So we could say that xy is perpendicular to xz. So this is a right triangle, so the answer is yes. And where's the right angle? Let me pull this down just a little bit so I have a little more space to write. The right angle is at x. That's what it asked us to say.